Good morning, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. The session will run over the next 120 minutes, including Q&A. This session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. He is passionate about technology and works on Azure, GCP, machine learning, and blockchain. He is also a Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you, Rashmita. I will share my screen. Okay, so good morning, everyone, and hopefully all of you are doing well. You are safe at home as well. And today we are going to talk about the modernization of the applications with Azure Services. So the various things which we'll be discussing in this in today's session will be we'll take one scenario. Like if you have joined me for previous sessions as well, you may have realized that we try to keep it aligned to some sort of customer scenario or case study, and then we discuss the services around that. So today also we'll take one example of one company, and this is the e-commerce website. It is running right now on premises in one virtual machine and in one physical server like that on prem, and we have to migrate the application and the database to the cloud. That's one of the requirement of this customer. And then we also have to suggest them how to modernize it, and we have to do it for them. So we will walk through the various things, various bits and pieces of how can you modernize the applications, what are the various type of design patterns which needs to be put into place, what needs to be, how do you make something which is scalable, how do you decouple the various layers of the solution, and how do you make it, how do you use which services to be used, which can make it, which can scale very easily. So we'll go through this in more in some time. We'll go in depth over there. So we'll talk about the CI/CD. We'll also have CI/CD with GitHub Actions as part of the today's session, and app services, database migration services, functions, Key Vault, and Azure Migrate, cache, databases, storage, VS Code, Kubernetes Spark. Many things will be there as part of the discussion as such. So the very first thing which I would like us to do is we would like to go through the scenario of the customer. So we'll spend, I can say, a big amount of time. Big amount of time will be like around 15 to 20 minutes to understand what is the problem statement, what do they have right now, what are they looking for, and then how are we going to do it. We'll practically see it also, and we'll also understand it in the whiteboard as well. So if I just zoom in into some of the things which I have placed now over here. So basically the name of the customer is also okay. So what this company does is they basically create various type of parts, and these parts are for various cars as such. They can be bicycle parts, they can be the parts coming from uh, all these different type of accessories or anything to do with cars, van, truck, utility, vehicle, and so on and so forth. So the name of the company is literally, sorry, the name of the company is literally Parts Unlimited. So Parts Unlimited. Now what they have done, or their business was running very well before COVID, and they they had uh, one they basically have around three locations from where they operate right now. And they started in 2008. They are based out of Washington as such, and they also have planned to sell their products in Mexico and in Brazil, apart from the US market, and then in future to other part of the world as well. So now what happened? They things were running very fine for them, but when COVID started, or just before COVID, the amount of business which they were doing was mostly offline, like or something which the amount of orders which they were getting for various parts. I'll open that website again, so it will give us something to look at. Okay, so the amount of orders which they were getting, for the, let's say, for engine oil and for various filters, battery, and maybe some wiring as such, and so on and so forth. So they were mostly offline as such, and a lot of professionals, a lot of mechanics, a lot of you can say people who upgrade the vehicles. They were their customer. So before COVID, a small portion of their business was done over the website. Rest was more of word of mouth and so on and so forth. But then what happened? COVID happened, and then they found that there is a sudden increase in the infrastructure, the traffic which is coming to the website, and their website was hosted on premises in these machines over here. And so this is one physical machine over here. This is one physical machine over there, and the website is .NET based, and they started facing scalability issue. The IT team was not very big in size. The IT team was having a small number of people who just so they had the typical scenario, right? So the IT team, there is a server room which is next to the IT team's location, and so that there are two rooms, and these small team is just managing few servers as such, and they were it was working out for them. But suddenly now the traffic is coming, things are crashing down. They tried to upgrade also on-prem itself, and they are looking for our help to take their solution to the cloud. They are looking for our help to do the migration. They are looking for our help to do the modernization of their application. So they also have database which is running in on premises, and this database is a Microsoft SQL database which is running on Windows Server 2008, the old one. So that also has to be taken care of. Now, so whenever we do any type of migration, there are different problems which we face. We have to do the migration. That's one thing which is very clear from the requirement. Secondly, we have to take care of scalability as well for them. We have to ensure that their website doesn't go down and it becomes more modern from this point onwards. And they have future plan of increasing the market in Brazil and increasing their market by going to other part of the world. And they have engaged one company, but the company is remotely located in Indonesia as such. So they are facing a lot of challenges when it comes to local, like somebody needs to be on ground itself to work. Okay, so one thing which is very clear is migration is definitely is one thing. And then what else? Like what are the various things which they can go for in next 5 years? And they want immediate migration because that is the need of the hour. So I'll just open one migration image. If I can copy this from my secondary screen and put it here. So when we talk about migration, it is check this out. There are various phases over there. And I'll see if I can open the picture. Okay, so great. Now, this is the image. Now, so there are various phases as such, like pre-migration, the real migration, and the post-migration. Now, the real migration or the migration phase is not the most is not the one which is the where you will have most challenges. That will be sort of what you can say easier versus the pre-migration phases. where you have to do the assessment. You have to do a lot of calculation as well, like total cost of ownership needs to be understood, whether your application can be taken to the cloud or not. We need to have the assessment from both, you can say, the compatibilities point of view as well. And now if you're taking the .NET application to the cloud, and we are also taking the database to the cloud, then we have to do the assessment for both of them. And so discovery basically we will stand for the like running some sort of tool, or maybe engaging with various teams and collecting the information about the on-premise processes. One of the problem we face when we do the discovery of for various machines is that, let's say you there were 5 applications and you took one application, and that application was depending on 3 4 machines as such. So there was a front end, middle tier, back end. So you were supposed to take all of them together to the cloud so the application doesn't break. But when you did that, maybe that application was also depending on some identity provider to get some token and then do the authentication and authorization. That thing was not very well documented, or let's say the team to which you discussed during the gathering of the information about the application, that team was not very sure about, so because of the tokens which are passing. So now we instead of that, we can also rely on the tools which we have. Like we have various type of discovery tools. You run them and they run for a period of time, and they check out the network traffic, they check out who is talking to who, and they give a dependency map. They give a proper uh, chart where we'll be able to understand that if this is the application server, then what are the all the servers which it is talking to. So that becomes a move group, and we move that group to the cloud, and will not break the application while doing that. So those that is very much required. Let me see if my whiteboard is active again. So I'll just go back there or not. Okay. So now, okay. So today we have to think from the application's point of view and from the databases point of view. Both for them, you have to do a discovery, assessment, and if there is anything which is not working out, if there is any blocking dependencies, or if there is anything which is not compatible with the cloud, we have to take care of it first. Then the migration phase will come, and then the will application migration, database migration, and then the connection strings, the connection configuration needs to be updated in a lot of locations. So we will be doing that thing. Now, during the post migration phases, we have to do the lot of optimization, remediation, and a lot of documentation needs to be changed as well. And if you have to deprovision after your successful migration to the cloud, you can deprovision the on-premise machines as well, right? So let me start from that. So how do you do this in Azure? Like if I have to start doing the assessment and the migration, then how do I practically do it? So if I take you to the to this, okay, I think the diagram is pretty big. It's taking some time for it to move around. Okay, we'll wait for it to come back. In the meantime, I'll open the VMs. So this is one server which is there on-prem. So right now my machine is in the cloud, but this is what I'm assuming, that this is what we are assuming to be on-premises. So this is one of the machines where the app is the front end is running, and so this is that one. And then we also have the database. Database is running on 2008. So which I will connect over here like that. So this is the one where DB is there. So now, okay, so I'll minimize them for now. So what the way in which we do it, or the way in which we have to do the assessment, is we go to Azure first. We create the Azure Migrate project over there. So Azure Migrate project is something like this. So I'll take you to my Azure subscription, and I'll just zoom in for you over here. Okay, so, and let's see if I can show you a couple of things here. Okay, so let me just quickly show you here. So Azure Migrate like that. So the very first thing is we create the Azure Migrate project in the cloud like that, this one, right? And now when we create that, so you have to come here and you have to basically select like what are you doing over there? Like are you moving the web applications or are you taking the databases to the cloud or are you taking the full virtual machines to the cloud, right? So that that has to be sort of selected. And once we select that, we also have to specify the source and the sync location as well. Like source is what? Like is it a physical server? Is it a virtual machine on premise? If it's a virtual machine, then is it running on Hyper-V or is it running on VMware's ESXi as such? And then, and if it is Microsoft's Hyper-V, then we have two disk formats, VHD and VHDX. So VHDX is yet not supported in the cloud. They are working on the support. It's all there in preview right now. So if it is VHDX and I have to do it today, then I have to convert my disk into something which is possible on Azure. So like I have to do a V2V migration, like virtual to virtual. And for physical machine, physical to virtual. So we have tools which can do all of that in one go. I don't have to do it separately. It's not the old days around like I remember around 10 years back, I used to use the tools PlateSpin and VMM also, Virtual Machine Manager, PlateSpin, and other tools to do everything manually, like physical to virtual migration, then run some script to convert that VHDX into VHD and then move it to Azure cloud. So those type of things now are are taken care by these tools and they do it end to end. So we create Azure Migrate first and we click on the web app option over there. And as part of the web app option, you actually have to create the project first in the web app option. I have this project, so it is already loading. Otherwise, it would have asked us to create the project over there. Once we make the project, we specify like what are we looking for. We are looking for assessment help as well. We have to do the assessment first, then we can do the real migration, and then the real migration part. So they have different like tools for the migration, tools for the assessment. So you come here, you download your tools, you install it, you take your tools and you install it on premises in the machines. So if I take you back to this, so this is my on premises web server, which is that green one, this one, where the current website is running. And the website which I showed you was actually, so you see this IP address, that IP address is of that machine as such. It's running on IIS web server there. So uh, I'll take you back to that. Okay, then if I show you the assistant tool, so this is the tool which we use, and it should load over here. Oh, I think multiple instances of that is running. I don't think if I can zoom right now inside this tool, but I will read the various the steps for you over here, which needs to be done over there. So you can see, if you can see on the left hand side, we have like the assessment report, login to Azure, migrate hub, Azure options, hybrid connections, migration result as well. So we basically click on the so what it does the discovery like that. So it's saying that there is one site which is available over here. Now I so this is my name of my website, default website. You can name it something else as well. So now it runs the reports like that. Like, okay, so 13 successful things, no warning right now. There is no problem with anything. So if you can see it does a lot of different type of checks over here, like check whether global modules are not standard. So when we are taking to the so this for this customer, we are going for platform as a services in Azure. And the reason behind going for platform as services is that they have a smaller IT team right now. They have requested that they do not want to do more management in the cloud as they are doing on-prem anyways. So they would like to uh, use the platform as services so that the backend can be taken care of by them, like the backend, the virtual machine management, the patching, and all of those things are now abstracted from them. They have requested for that. So if you know that in Azure, when we do the migration, and we take the applications to Azure, we have this service called as app services. That's the one. So we are going for app services as such. So the very first thing which I do is I open that back again for all of us to read. Now, if I read a couple of more things, so that, okay, so check out for any global modules which are not applicable in Azure App Services. Check for multiple application pool outs used by this site. check for any errors in the IS configuration, check to see if the application is using HTTPS, and so on and so forth. So it does the minimum baseline checks over there for making sure that this should run in app services or not. If it doesn't run, then we'll think about lift and shift, and we will take the full machine to the cloud itself, and then we'll just tell the customer that either you start thinking about making the application, redesigning it, or you can say re-architecting it in the cloud. Go for that either, but in the meantime, go for the we can say go for infrastructure as service, because your application doesn't support the modern platform. So that can be taken care of in a later phase then. So right now they don't have that issue. It's successful for them. So we can get the report out of it here as well. And this is where we have to log in into Azure. I think I have to do it again anyways. So it will open the Azure portal, and I will just copy that. This is the metadata handshake which is happening. And yeah, so okay, so it understands that there is one project which is there in the cloud, and it has been signed in. So great. Now if I go back, I can select my project which I made in the cloud. It's very small right now. In this portal I cannot zoom in. I'll try. Let me see Control plus if it works over there or not. So this is basically the name of the project which I gave in the cloud. Parts Unlimited. That's the name of the company over here. Now, okay. So what options are there? What do I want to do? Which resource group do I want to go for? What is the name of my destination website? I have what is the do I have anything which is already running, or do I want to make another app service plan in the cloud? And then in which reason uh, Azure region is it going to be in? So all of these things needs to be selected over here. And once you have done it, this will do the migration of your app to the cloud. If you finish all the things, it will do it again one more time. I'll show you the one which we have already kept ready. So let's go and have a look at the Azure services as well. Like what is this? What is the meaning of app services, and how do they work? I'll open another tab so we can switch between these tabs without going back and forth over there. So I have some little bit of setup here. Don't get worried about that. But I will just look for the app services. Okay, so this is my app service plan. This one. See, now when we are working with so if I give an analogy, on premise we have, like, my laptop is having around some 16 GB RAM right now. Physical hardware, like it's a physical thing as such right now. So when we go to the cloud and we go to virtual machines, then we have same concept, virtual RAM, virtual CPU. But when we go for the platform as a services, now it's not applicable anymore, because there is no VM. It's not, there is nothing virtual in a sense. So they have created new type of pricing for us. So that new type of pricing is part of of this app service plan. So for example, how much RAM do I want at the backend? But I won't call this RAM. We'll basically have various type of plans over there, which will have the RAM and other variations inside it. So premium 7 GB RAM, 14 GB RAM, and what else will it provide me? It can scale to 20 instances. I would love to have that for this company. If it can scale, if it can have one load balancer inside the app services and scale to 20 instances when the load comes, and scale down to maybe one instance when the load is not there, that is something which they are looking for. So we are going for this. And traffic manager is one DNS routing service, and the how many daily backups that can be done. So this will just remove that dependency on the parts unlimited limited IT team to take the backup or make the another backup service, or to worry about this. The backup is can be taken care for them as part of this plan over here. So this is what we have suggested to them. And if I take you one page back, and that's what we are using. So this is the wrapper. It's only the wrapper. It's not the real thing. And what is there inside that wrapper is my web app. So I'll just sort them in the order. Okay, this one, the first one. So this is where that migration has happened to this particular website. Now, I can show you. It will be working because I have this setup, but I'll show you what I have done before it was working. So we'll keep this page open over here, and I'll take you back to my diagram. So the purpose of the Azure Migrate was to create the various type of to use these tools which are provided for the assessment purpose, and assessment purpose will also do discovery along with that, and then for the migration as well. If everything is fine, we can do that. So that tool basically migrated the application to the app service. Now inside the app services, we have different deployment slots over there. Like you can have up to you can say 20 deployment slots over there. Uh, so 20 deployment slots means like I can have production, prod, stage, and so on and so forth over there. So the reason we do it in this manner is like later on we can do when we are doing this the continuous deployment from that CI/CD pipeline. Then we can have the mechanism of swapping it. If something goes wrong, then we can roll back and so on and so forth. So this is the app service plan. It's a platform and service solution over here, and this is the production deployment slot, uh, and and the end customer is accessing that as we are speaking. Can access that as we are speaking. So it will have one deployment slot which is by default. So the first one is called as prod. Others you can name it as such. You can name it, and there can be many of them. So the application went to the cloud first. Now then what happened? The next thing which it's not working because the database was not there. So what we had to do, we as part of the move group, we are taking the DB as well. I'll slightly zoom out. I think it's too zoomed in right now. So the whiteboard is actually struggling with rendering of all the colors and graphics. If I slightly zoom out, then it should be moving around freely. This is way free than the previous one. So now if I take you back to the 2008 server, which loves to get disconnected. So we'll connect it back again. But okay, so this is the old one. So you will see that uh, I will just connect one more time. Oh, and that's, if you remember, this is the old one, right? That's how it looks like. So what I have done here is I have installed for the databases, we have installed the database migration assistant tool. So this and before we can say uh, before we can come even over here, we basically go back and we click on the other option which we have, databases, and then we specify which database are we taking, uh, and you can say source and sync and all those type of configuration. So we are looking for both the type of tools, the assessment tools and the one which can do the migration also if everything is fine with the assessment as such. And the reports will be there in the cloud. You can see these ones over here. I can get the detailed reports. So what I have done, I just made the project. This came up. I downloaded the tool. I installed it in this 2008 server over here where the DB is there, and that's how it looks like. So you click on this plus option over here, and you maximize the screen as well. You see this assessment or migration. What are you looking for? There's a radio button over here. So I'm looking for assessment right now. So what is I mean? Which what is your you can say name of the assessment project? So this is my, let's say I'm doing a uh, live demo or something. Okay, so assessment type, what are you looking for? Integration services or database engine? What type of source do you have? Is it AWS RDS? No, it's not AWS RDS right now. It's SQL only on premise. So where are we taking it? So is it going to be running in a virtual machine in the cloud, or is it going to be running in Azure SQL Databases PaaS solution? Is it going to be running in this hybrid of IaaS and PaaS called as managed instances, where you can do lift and shift? Is it going to run over there, or is it going to run in another SQL server somewhere, not in the cloud, but let's say on premise somewhere, another one? So mine is the first one over there, and I basically create this assessment. It checks for the database compatibility and check for the features which will fail if we go to the cloud. So there should be one run option on the right side, and we will see if I can zoom out. So I have to, oh, luckily it's there. Otherwise, I have to remember the passwords. I have them somewhere in my secondary screen noted down, and hopefully the password. Okay, then which database do I have? I only have one, parts unlimited, and then I would like to go next, and would like to go slightly here and on the top as well. Okay, so is this the database which I'm looking for? Yeah, and then please do the assessment for me. Start the assessment like this. Okay, so there is no, it's saying there is no errors with the feature compatibility is there. And if I go to the left side, any other further issues, it's saying no, there are no issues over here. But this is the place where when we find issues, we have to fix them before taking the DBs to the cloud. Okay, so things were working fine. So what we did, we went ahead and we went for the other one. And we are saying migration as such. Now, when you are doing the migration, you have many options. Like, do you want to take the schema only, like the tables and the table structure, only that? Or do you want to take the tables and the data also along with it? So how do you want to do that? Secondly, we also have the capability of doing it in live mode or in a type of offline mode. So online mode means, so there is an online mode and offline mode. So online mode will mean that the uh, okay, that basically means that people are still using it. It's being is used as such, and the sync is going continuously. Is going to happen continuously to the cloud. So this is the online mode over there. And one day when I am okay, where my you can say initial synchronization has happened, and now delta is going on. And once I have the confidence that things are okay, what we will do, we will basically take a small cutover over here. So you still need a downtime, and cutover will be that small downtime which you take over here, but it will be smaller because the initial sync has already happened in online manner. Now, okay, so what are my thought processes when we have to select this? Now, some jobs will be running over here, which will be doing the movement of your data. So definitely those jobs are lightweight, but they will be sort of consuming some CPU and RAM and so on and so forth of that machine. So if your application is very mission critical and you don't have extra resources over there, you would like to think whether you want to do this in online mode or not. So those type of thoughts will come to your mind. You will check it out. Second thing is offline mode. Now offline mode has a bigger, you can say, downtime. Offline is literally shut down the server on-prem and then let the migration happen. And once the migration has happened, that's your once the cutover, you have taken the cutover, everything has synced to the cloud. You are in the cloud then from that point onwards. So online and offline both modes are available, and based on your need, use them. So what I have done is the online migration, and it has already been done uh, in my case over here. So the 2008 server loves to get disconnected, so we'll say connect back. It gets disconnected, I think, because when I change the focus from here, this tool which I'm using, the connection manager, it's not able to maintain the I think the rendering of that particular RDP right now. Normal RDP doesn't have that issue. So okay, now we do the migration here. We fill up these details. It will and it's a pretty simple process. I'll show you. Let's say okay, migration to Azure SQL. Okay, from what I'm taking to where am I going, and what do I want to take? Schema or the schema plus data or only data and so on and so forth. So we have to connect to the source server, and it's already there. And I think the password is already copied. So okay, and we'll just say next. That's the database which got selected, and it will ask us the cloud endpoint as well. What is the name of your cloud machine? So my cloud server is having this URL, database.windows.net, and I am looking for the SQL authentication. That's the name of the user, my admin user in the SQL in cloud, and then the password will go like that and should connect. And then we'll just say next. Okay, now I selected the option where only schema was there. So tables are there. All which table do I want to take, which I don't want to take. So I can see that we have the various tables over here, like the items in the cart, user tokens, users, logins, order details, order product, stores, all those different tables are there. I'm saying generate the SQL script. So this will generate the SQL script equivalent to all those tables. And then once this is done, I'll say deploy schema. As soon as I say deploy schema, this table structure will get created in the cloud over there. So this was the schema only option. And the other option was schema plus data or data only. So based on that, we we have the flexibility of selecting and then doing it with this tool in a very smooth manner. The problems will occur if you have a bad internet or your express route over here is not really good. Then those type of practical problems will happen. So you have to take care of your network is on you and your company to maintain. And any firewall based whitelisting needs to be done. Then after that, once all those things are done, this tool is smart enough to sync things fairly well. Now, okay, so we were able to take both the things to the cloud. The application also went to the cloud in a PaaS solution. The Azure, the database also went there in the Azure as Azure SQL, which is a PaaS solution. So we over here now, but by just using that, the platform as service solutions and just by going to the cloud, nothing becomes highly scalable. We have to really configure things. So the very first problem which we had is the application was not connecting to the database because it's a different connection string, right? So we went manually to the cloud. We'll go like to the cloud like that, and we will just find the connection string of the. I'll see if I can duplicate one more time. So uh, configuration. This is my app services over here, and right now, if you're aware of the principles like we have principles like 12-factor app. Like if you are going for cloud, what are the factors or what are the characteristics which your application should have? We discussed that particular concept 3 to 4 sessions back. 12-factor app. So one of the factor of that 12-factor app is to maintain the configuration outside the application. Don't hard code it. Use variables. The configuration should be maintained in some sort of GitHub repository and so on and so forth. Not really GitHub, but somewhere needs to be external to the application. So we are doing it. So first thing which we are doing is we haven't connected to any repository right now, but we would like to see whether it works or not. So we went to connection strings and we made the connection string over here. We clicked on new. We filled up the information over there. I hope this is the one. Double click on it so it will show like that. So this is the connection string I copied from Azure SQL and I just gave it over here and just saved it. So that's one thing. And then we were able to find that it runs, like it's still operational. Now, how can we have application which is highly scalable in Azure? So I am looking for one picture I would like to show you. I'll go to the Architect Center of Microsoft Azure, and I will just look for the architecture which they have, which looks like this. So this is a very typical. This is not very you can say it's only in one region right now, but it contains this particular picture contains this architecture contains all the various services which you have to consider or when you create highly scalable applications. So if we check out from somewhere, Azure AD authentication and authorization can be taken care by that identity provider. DNS is going to we can make the CNAME records over there. We can make the A records over there or AAA records over there. And we can also buy the domain name from Microsoft only. We don't have to go anywhere else. So if I would like to buy a proper domain name for my application, I just have to scroll down and custom domain names. And I can look for any names which I like over here. And they have a tie-up with the domain name providers. So whatever I type there, if it is available, I will be able to save it. It will be applicable. It will be given to me, and it will be saved, or you can say restrict, or you can say assigned to me. And the backend clouds, the domain name providers, they know that. So Microsoft did a tie-up with all of them. GoDaddy, BigRock, and other providers are there. I think in different countries, different providers will be there. So I can go for this. I can maintain my own domains. I can maintain my own domain names. I can maintain the name servers also in Azure now by using Azure DNS services. So if something goes wrong from the DNS point of view, I don't have to rely on the GoDaddy to solve it for me. I have the capability of handling, and we have the reliability of Azure and the Azure services and the redundancy and the multiple servers which they are running to ensure that things are operational and we have more control. Front door is just like this is a highway to internet, like sorry, highway to the cloud. What happens like when so imagine we are sitting over here somewhere in this cloud. So when we hit the application, the traffic goes over internet and then it hits the application in the data center of Azure. So the and when things go over internet, there is a lot of hops which may happen over there, and your traffic, and it will take time. Whatever practical time it will take from your house to from your laptop to for the traffic to hit wherever the application is hosted, that practical time will be there. Now, when we use this front door service, it basically let us use their fiber optic connections at the backend. So there are POP locations or point of presence locations. So the traffic will be picked up by the location which is nearest to me. So I'm in Bangalore right now. So whichever POP location is nearest to me, that traffic will resolve to that, and then the traffic then will flow over their backbone, Microsoft's own backbone fiber optic connection. So then I will be getting, you can say, premium service from that point onward. So the latency will come down from me, from my location to this location over there. That latency will be brought down by that. It's a pretty nice service. We call it uh, it's called as application delivery network, ADN. So this is CDN, that's different. So now another thing which we have suggested to them is that you have so many website pictures over there. They have these sliders are there, discount is going on, product catalog is having so many images. So these images at the backend needs to be stored somewhere. And that location should be available to all the people globally with in as you can say as fast as possible. So for this static content, all of this product catalog images, all the images which are there, or the CSS, JavaScript files, or anything which we want to, which is static, which can be cached, we use the content delivery network. So over here. So there's a question in the chat, what is POP? So POP basically means, let's see if I can write on this or not. Okay. So POP basically means that if you see this diagram over here, there will be, you see these caching locations, so which are globally distributed, these circles right now. So these are caching locations, and one of them is called as point of presence, POP location. So the static content will be cached over there. And when I or me or anyone from my locality hit the website, the tags in their pages will be pointing to that, not to the original source content. And from here, static data will be distributed. So and it will be cached there, and we will have the control on how much time it should be cached for, how do we flush out the cache, and so on and so forth. So that particular caching location near my house or near my locality will be POP, point of presence. Okay, so okay, then this part I'll take it up in my diagram. So if I just take you back to that one. Okay, let me read the questions in the meantime. So okay, can you suggest Discovery needs to be installed at all three on-premise machines or only on one? It depends on network reach. We have tools which, if network is there, they can discover machines on your network, and they don't have to be on individual machines. So, no, not really. The second question is uh, P2V. P2V today is done by Azure Migrate. PlateSpin is one of the answer for that. PlateSpin or Virtual Machine Manager, or just look for these tools. PlateSpin will be better than VMM. VMM is a different thing, and it just tends to also do P2V when required. Not any tool for NoSQL. No, we have tools for NoSQL as well. If in case you want to migrate MongoDB, we can take it to the cloud, and possible. database migration service, DMS is the service which can do all of that. Okay, so one more thing. Now, what they are looking for. So what we have done is, apart from this, we have also decoupled the web role and the worker role with one queue over here. So this queue is maintained or is created in Azure App Services. Sorry, Azure Storage account queues. And this queue is having a length of 500 terabytes. But it will be practical. Like if in that point in time, if it is having 20 MB of messages, then we are paying only for 20 MB, but it can stretch to 500 terabytes. The message size will be 64 KB. So when a lot of orders comes over here, there is no one-to-one relationship. The web roles simply can write in the queue, and that we have some worker roles over here, Azure Function, which will pick up which will also scale out. This is serverless component where this is like AWS Lambda or serverless as such. So it will pick up these XML messages and will place the order in the DB. So we have this order queue over there, which we have put in the solution. Now, one more thing which they have requested us to provide and give it to them is that the functionality of making invoices. So if I go to the cloud version of it, and if I see if I have that open or not. Okay, so if I log in here, I am logged in there. Okay, so then if I buy something, if I'm logged in, then I want to buy this. So add to cart, checkout, and then some details. So right, so okay, promo code. Yeah, okay. Otherwise, payment gateway needs to be integrated, right? So don't have that right now. Okay, so what will happen is at this point in time, they wanted us to generate that. So they wanted us to provide that the functionality that the end user should be able to download the invoices in a PDF manner. So what we have done for them is, okay, let me check. Okay. Oh yeah, sorry, this was the page. Yeah, correct. So what we have done for them, or what I should do, I can create one more. So what happens? This download option doesn't come initially. Then because and at that point in time, the Azure function which is there, this one, it basically once the order has been placed, once the payment has been done, this Azure function goes and generate the PDF, and that PDF is stored in the storage account in as a blob over there, and that blob's link is what is visible right now, which can be downloaded. So if I click on it, and if I just show it to you, this is the details which I just gave. Shivam for something random numbers, and we are looking for the engine oil. So we got uh, this is the invoicing mechanism. So this is being taken care by Azure Function. Now, why we went for that? The reason we went for it because this is totally serverless. Now, if there is no traffic, then it's going to scale down to 0 instances, and we don't have to pay for it apart from any storage which it is using at the backend. And whenever it there will be a lot of traffic, then it will scale out accordingly over there based on our configuration as well. We can put limits, and we do put limits. So scaling in and out will be taken care of, and it, in pure serverless manner will be that service. So if there are a lot of orders being placed in that point in time, then it will have more instances handling it. If there are less orders, then it will come down and will be able to work accordingly. And we actually have created that Azure function as queue triggered function. So whenever the messages are there in the queue, it automatically gets triggered and starts processing it, which processing basically means put it inside the database. When you get the acknowledgement, create the PDF, store it inside the storage account, which is available for the user to download. That's what we means what it does right now. I'll give you this example to deploy as part of today's, you can say, session as well. And once you deploy it, you have to code it. So I'll show you what I have already done over here in one of these machines is the full deployment of that. So this is that. This is the I think the other one is the one. So yeah, function app is here. So this is the function app which has been deployed there as such. So now, okay, now once we have provided all of this, the near real time or their today's problem have been solved. One more thing which they have requested us to provide is the capability of having CI and CD as such. So I'm pretty sure you are already aware of CI/CD. I'll just give you a little bit of like 2 minutes recap of it, and we have done very nice big long sessions on GitHub Actions and CI/CD in as well. So please find us find me on the Reactor page on YouTube, and you can check out those sessions on GitHub Actions as well. Okay, just to summarize it right now, we have, so as you already know that Azure DevOps, not Azure DevOps, DevOps, or the practical problem which we are facing is that there was a lot of delay that used to happen between the requirement gathering from the customer and then finally when the product is delivered to them, and that the difference between that time was of, you can say, 6 months and more than that as well at times. So by the time we deliver the product back, the customer's requirement may have changed. May are looking for more things. They don't like the old one, and then we again go back in that long cycle. So instead of long cycles, the new thing is we should have small cycles, something which is a smaller, which is more, you can say, iterative, smaller, and the as part of the DevOps practices, we try to deliver the value to the end customer in small iterative cycles, and we gather the information, we gather the requirements regularly, we gather the we build on those, we learn from the mistakes, we understand from their feedback, and we further go in the iterative cycle again. So if I have to do that practically, then there are a lot of problems which happen. So the solution is CI/CD. So now what I can do is all of these are my developers as such who are working on the Parts Unlimited website over there, and from what we have suggested for them, or what we have done for this company, is we have deployed their CI and CD pipeline. I'll show you the details of that. But before I go there, the continuous integration is basically, let's say this is the developer's laptop, and now he wants to check in the code in the repository. So when you do that, a lot of different scans needs to happen. Like the code quality needs to be checked. We need to check whether there is any secret which is embedded there or not, which we cannot do. So secret should not be there. So all those scans, all the test, all the code quality check needs to happen. And where the dependencies which are being used to develop the application right now, we have to scan them for vulnerabilities as well. Are they vulnerable? What is the, and is which version is a stable one, and so on and so forth. All those things needs to be taken care over here. Now, when we do all of this type of check, like you scan something, you run some test on top of it, you do integration testing on top of it. So anything which you do, you need some compute to do it. So the compute which is there provided by GitHub Actions is called as runner. They call it runner, like the VM is called as runner. So it's literally a VM, virtual machine, but or it can be Linux and Windows oriented, both as such. I think today we are using Windows one, and in the previous sessions we have only used the Linux ones in all the locations. I will verify that from the GitHub flow. Now, so this is the compute. So anything which runs, which builds, anything which computes. For that, I need resources. So the computation is called as runners in the GitHub Actions, and these runners can be cloud hosted, or sorry, GitHub hosted. So then we don't have to worry about them, or they can be in my subscription also, so self-hosted. So both options are there wherever the runners are. And if you work with Azure DevOps, you know the same thing as agents. We call them agents in Azure DevOps. Here we call them runners. So they are the same thing. Now, what my CI pipeline is going to do, it is whenever these the developers are making those incremental updates, or they are checking the code, we'll scan for the quality vulnerabilities. We'll shift left in security. We'll try to implement security best practices as soon as possible in the CI/CD pipeline. So that is called a shift left. Now, once this is done, finally some artifact will be created. So this artifact is the output of that CI pipeline, and this artifact, once created, will be stored somewhere. So this artifact can be your release, or this artifact can be the Docker image also, where and that Docker image is now is stored somewhere, like in Azure Container Registry, or in Docker Hub, or in any other location which you want to use. So that is that. Now the CD, what is a continuous delivery and deployment? Continuous delivery basically means that I would love to be confident enough that whatever we have built it runs. If I deploy this in production one day, whether it will run or not. So I want to get that confidence. So how can I get that confidence? I can do test on top of it. I can deploy it. I can do the various type of test on top of it. If it still runs, uh, then I'm pretty confident it may run in production also. So this is where we have the different environments, like test environments, UAT, production as such. So continuous delivery means that you didn't deploy, right? But when the deployment pipeline goes till the production, it calls as continuous deployment. So there's difference between continuous delivery and deployment. So we create the environment over here. Then or maybe environment is already there. Basically, you deploy. So deploy, and some tests are done on top of it. Then in UAT also, the environment is already existing, or you deploy, and then some, let's say we deploy, and then we do some test on top of it. When we are confident that, okay, this is something which we are looking for, we can do the continuous deployment. And the pipeline basically goes till the production machine, so which we have configured for them. So as part of the CD, the output, the final deployment happens in the okay, I'll just zoom out in my diagram and I'll see if I can show that. Okay, so what we have done for them is we have created another slot inside the app services. So, and this slot is called a stage slot over there. So the deployment is happening to the stage slot over there, like this. And then there is a swap mechanism. That swap mechanism can be automated, can be manual, both options are there, but we need some sort of human to be aware of when that happens. Like we need human release gates over there. So how do you automate all of this, right? How do you create this CI/CD pipeline? So I'll take you to my GitHub repository, and this is the one where we have pushed the code of the entire, we can say, entire application, which is the one which I was showing you, a part of the Parts Unlimited company over here. This is their private repository right now. So inside that, if you want to use GitHub Actions, you basically have to create this folder, .github and workflows. If you put the file anywhere else apart from this location, it will not run. So this is mandatory. Now, if I click on it, if I show you what I have, this is the one which I did. That was, yeah, let me show the other one first. This is the one which I just made to show you what are the basics of GitHub action over here. So the name of the workflow as such, and then when will it trigger? Like the workflow should trigger at because of some reason as such. So what that trigger can be, like the push happens in the master branch, or the push happens in any other branch as such. You can specify that. So this on basically means like when will this workflow trigger? which we are defining over there. Now, before I read this for you, I think I should have mentioned earlier, but the workflow is basically looking something like this. So imagine this box to be the workflow, the full file over there, right? Then basically inside that we have these small jobs as such. So let's say this is some one job, and then there are some steps over there. So these small steps are there like this. So these small steps are either written by us, or they are provided by uh, or you can say are provided by GitHub, or they are made by some other company and they are provided in the marketplace, or maybe they are made by some other person also and it's public, so we are able to use it. So that word comes, GitHub action comes from the ready-made steps which are there. Like if I have to deploy this, I have to log it into Azure. So if that particular action is provided by GitHub or Microsoft, then I don't have to write that PowerShell script. I don't have to write that CLI script. I don't have to write it myself. I can just use what they have provided. So that particular functionality of reusing and having a piece of code which can, a piece of a keyword or a function which can do that particular step is called as GitHub action. That's literally the meaning of it. So if I take you back, so on means when will it trigger? Then the okay, this is that job, the inner box which we are creating, and then what's the runner type, right? So the runner was the machine where this particular flow will execute. Like whatever we have written will run on the runners. We need computation to do practical things. So we specify like that, like runs on what. So these are keywords. You have to maybe look up in their documentation and provide it over there. So this Ubuntu latest is the runner provided, which is hosted by GitHub. So it's a GitHub hosted runner, cloud hosted like that. I don't have to make it myself. Then what are the steps which are there? So these steps were those individual boxes over there, the inner ones which are running. It is totally possible. I have multiple jobs, right? Now jobs can be sequential, can be parallel. These steps are sequential inside the job. You can skip it. You can do all those type of things. If you don't want to run any particular step, all those logics are possible. Notice this. So this will check out the code. My screen got stuck. Let me refresh this page once. Okay, now. Okay, so so one of the step is check out the code. The second step over here is like hello world. Okay, great. And then it like multi-line steps can be there. So how many steps are there right now? We have three in this. Someone like this is the meaning of GitHub action. Somebody has already provided us that particular GitHub action as such. Now I'll show you the other file which I created. This is the one which was default available there. I clicked on it and it got created. And I thought that I will just show it to you before I show the other one. So this is the one which we made as such. So this one is called as build and deploy the application to Azure. It's going to run on push. We can specify more details there actually, like on but in which particular branch, when the push happens in which particular branch, then it should trigger. Okay, some environment variables are there, like my Azure web app name is there, the package path, the deployment slot. I'm deploying in staging right now. I don't want to do anything in production. I will do this in staging over there. So if I do that, and I hope the whiteboard stops misbehaving, but great. Uh, so .NET version and the resource group name, that's my reactor RG. Okay, and then which runner are we using for this? Windows 2019 runner, and the various steps which are there in the job. So this is my job, build and deploy. That's the name of the job. And then what are the steps over there? Check out the code from the repo. The next one is set up the .NET Core and use this particular action which is provided by GitHub or Microsoft itself, and use that. So we don't have to write it ourselves. Then which pick up the environment from the variable, and then .NET build and publish. So as part of this, run these two things over there. So .NET build, .NET publish. So where will this run? So if you remember, the runner was there. So if you go inside the runner is one machine in this point in time. So it's just imagine like it is running in the console over there. That's what you can imagine as. Now, okay, then finally, run Azure Web App Deploy action with published configuration. Pretty big name, but basically what it does the deploy. So Azure Web App Deploy version 2. It's a one of the GitHub actions which is provided as such. Let me Google for this. I'll just show it to you. How will you in future find more of them? So I think maybe this should be the one. So there is a marketplace. Go and find it, and on that marketplace, you will find the GitHub actions here. So here, and then you search for the company which you are looking for, what the cloud environment or what you are looking for, and then just search for it. You will find these. So the one which I was showing you, I found it from this page only, Azure Web App, and other options are also here. So let's click on one of them. So basically what it does, and the previous page was the correct page, and this is where it is being used in the over here, like this, over there. Now, so we have done this. Now, how does it run, right? So if I do any operation, which is on which we have defined in the push logic, then it automatically runs. And if I click on this action over here, these are the previous runs which are there. And for example, this is the one when I was setting up this scenario in the morning. So this is the one which ran for 5 minutes, and it is having all these steps over there that the okay. Okay, so if you can see that operating system, some secret sources, run the first action, then what happened over there, then run the second action, set up the .NET app, then the third one, and so on and so forth, the complete job. And if any error comes, this is where we find it and we troubleshoot it from that point onwards. So this we have set up for them. And finally, once now from this point onwards, whenever there is any new feature which is needs to be released, that deployment will happen to the stage slot, and then the one of the administrator needs to go, or we can automate this, but we would definitely want to have some human releases over there, because when things goes in production, we need the human gates as such, like the approval mechanism. So we can totally automate it, and I will just show you that. Okay, so this is my production instance. This is the one which we are not touching, but there is another staging one as well, where the deployment is going to happen. So you can just have a look at that from the deployment slots, and I can click on the name which I will see, the other one. Okay, so that CD deploys here in the staging environment. Then we check it out whether it's run fine or what are the issues with it, and so on and so forth. If it is running, everything is fine over here. Everything is working. All your new functionalities are also working over there. Then you just go back and you do this swap of these slots. So now it will swap the source with the target. Source is the production, target is the stage. And this swap happens very fast, like it happens within minutes as such. So so imagine if something goes wrong, we are able to roll back very quickly. So now all of these are we have already suggested all of these two things to the company, and we have deployed this for them, and this sort of solves their real-time problem, or this solves the problem which they have in this point in time, because and the problem was that because of COVID, the scalability, the applications were not scaling on premise. They were they had a small team, and they wanted our help to take them to the cloud and go to the platform as services. So and do the and create one CI/CD pipeline for them, for which the Indonesia team can use the developers which are sitting in Indonesia, for to whom they have outsourced the app improvements and development as such. So they will be using that logic. Now, so this is the short-term current problem resolved with least amount of efforts, with least amount of steps, least amount of, you can say, and definitely least amount of maintenance also afterwards, because in clouds, in the cloud we went for all the platform as a service solution. Now I'll just read your questions first, and after that I'll show you the further advancements which we are suggesting to them, and we will go in the Kubernetes and in the other requirements which they have told us around the future uh, data analytics and big data analytics requirements, and how can we uh, align what they have today with that thing in next 2 to 5 years. How can they make that smooth change, so when they go to Brazil, when they go to other part of the world, they don't have to rely on, they can do more data oriented steps can be performed, data oriented recommendations can happen in real time, data oriented edge can be achieved in the business. So I'll just take your questions first on what I have shown till now, then I'll go to the next part, and I'll find it in my whiteboard as well where it went. So if we use Azure App Services, by default it uses CDN. No, not really. Uh, how will it know which? There are two things now. See, do you want to cache your entire website? That's one line of thought. Secondly, I don't want to cache my entire website. I want to cache the video playing inside the website, and that video, and maybe I want to cache both of them. Like they both should get cached. So then that video, and then if I do that, then I have to ensure that the anchor tag which you have, or the tag which you have in the web app, should actually not be pointing to the original source, but the URL should be pointing to the POPs URL. Then only the content will come from there. So those things we have to perform as such. Like our developers will sit and will ensure it is there. Okay, I'll take more questions. So a DMS service, Abhijit, there is a service called as data migration service, a database migration service in Azure, DMS. Look for it. That has a support for your non-relational databases. Do we have examples of Java and Linux? We may have uh, this Java and Linux. Definitely we'll have examples of Java and Linux, and we can check it out in the. I'll find if I can look for any link. Otherwise, you can check in the original Azure web app documentation. They will have hundreds of references for them. Where does it where does it store our package to be swapped? The uh, the source of my code is in GitHub. The the compiled releases are also there. If images, then the images are in ACR. And it at the backend, they take care of the storage. I don't have to configure like where are they going to store it. In some sort of local disk at the backend, you can say VMs which they are maintaining. There will be some local disk over there, and they will be managing the source code inside that, or some sort of file locally on that machine in a disk. That we don't configure. That they provide. Now, okay. So another thing which we are suggesting uh, to this company, uh, looking at their future enhancements, is that that uh, later on they have to scale. A lot of scalability issues will happen. Uh, not really, but you can say because there's a proper e-commerce website, and if they go global in a sense, like they go for Brazil's location and other locations which they have mentioned in the example, then one day we would like to move away from the monolithic approach which we are taking right now into microservice approach, which is right now not configured, but in future we are suggesting to them, then go for the approach. We'll be having more We can use the different data stores at the backend. We can use different programming languages. We can have synchronous, asynchronous communication in your microservices. We can scale them separately. We can provide those smaller services. And if there is any outage in one of the service, it will be having least or no effect on the other services or instances which are running at that point in time. So microservices approach is what we have uh, also suggested to them, not in the short term, because they really right now don't have either the IT skills or the skills in you can say the developers which are sitting in Indonesia are trying to cope up just by running this in the cloud, and their short term problem has been solved by going to the cloud. But on a longer term, we are suggesting them go for the Azure Kubernetes Services, which is the managed Kubernetes solution on Azure. And if I just walk you through this, I'm not sure how much of this will make sense because it takes time to explain all of this. I'll do my best. And right, so we have these various components in the Kubernetes cluster. Kubernetes is the container orchestrator, and that Kubernetes in Azure is AKS, Azure Kubernetes Services. So it's the open source one plus the additional networking interfaces which they have provided, and some other hardening which they have done, and some other you can say the master node is free of cost. 3 master will be running, but you don't have to manage it. So this one which you see in the screen is totally taken care by them. I don't have to pay for it, free of cost. And the high availability of the key value pair is also on them, not on me. So I will love that to happen because that is the brain of Kubernetes. That's the key value pair. All the states are there in this HCD. If that anything happens to that, it will be pretty. It will be an issue for me. So that needs to be taken care if I run this myself. Now, but they are running 3 copies of the master default for me. So that helps in reducing the management. Okay, now what typically happens in Kubernetes is, let's say this guy, one of the future green color persona from 5 years in future, just one day opens his laptop and runs one command over there, doing some kubectl apply. So what happens? We have 4 components in Kubernetes, like 4 major components. HCD, that's a state. That's where the states are maintained. Scheduler is, I will see what it does. It just binds the pod to the node. And we have API server, which exposes all the APIs, internal, external, and controllers are there. A lot of controllers are there, different type of controllers, but they together we are calling as controller right now. And individually there will be various different type of things. So controllers are the main operational loops. They do stuff, uh, and there will be many of them. We can also make our own controllers, and we'll call them operators. We'll just change the name, and the custom controllers are called as operators, and we extend the functionalities of Kubernetes by them. So that's what I am coming to, the Spark operator. So what we are suggesting to them is go for Kubernetes. It's a very nice orchestration solution where you can run your microservices, and it will be having these 4 components in the master node, and then the flow happens like this. So if I please have a look at that. This is this only a little zoomed in over there. So whenever you do this kubectl apply, and let's say we are doing some deployment over there, and we want to run 3 copies of the login system or the payment gateway, right? Something we are running. So what happens? The API server basically goes in. It basically one entry gets created in this HCD like deployment, and then the entry got created. In Kubernetes, everybody is listening to everybody like that. So we call them, they are watching. There is a watching concept. Bindings are there. So then what happens? There is a controller over here, which is called as replica set. The first one was called as deployment controller. The next one is called as replica set. Basically, it comes and create the replica. Then what happens? It also goes and dies as such. Not dies, it just goes away. Then what happens? The scheduler comes up. Now scheduler says that okay, it goes and scans your the cluster. It looks for there are 2 type of logics it goes for, predicates and priorities as such. Like some hardcore rules which cannot be avoided, and priorities are like, yeah, if possible, let's do it. That those type of differences. So it goes and scans all the servers. It finds the best nodes where my containers can run. Now it finds that it does the filtering it on the uh, feasible nodes. It does the sorting on top of it, finds the best one, puts a rank to it, and says okay. What it does finally, when it knows where we want to run it, it goes back and does the entry in the it just does the binding of the a pod to the node. So it says, sorry, over here, like pod, this is on node 1, you are on node 1, you are on node 2. That's all. Then what happens after this? The kubelet, which we have another agent which is running in the on the worker level over here. This basically gets the information from the API server that something needs to be scheduled. Sorry, something needs to be created. So this starts creating it over here. It pulls the image from the image repository, the Docker hub, and so on and so forth, which I think I didn't make it over there, but somewhere from where it is pulling the image. So all of those things are going on, and the status is getting changed. So pods are getting created, and after some time, pods are running also. So all the details are maintained in HCD, and this is my pod. So in future, one of the microservice will be running here. So this is the login service. Another instance may be here, and another login service instance may be there, or maybe another, we can say something else is also running there. So all these various microservice instances will be there, and you can imagine the cluster is totally filled up with so many pods which are running over there based on the limits which we have in the cluster, and also based on the upper RAM resources and CPU as well. Okay, so now if they go for Kubernetes in, let's say, in future, where they are running their services or their applications, there is another very interesting concept, which is a very practical problem, which we call as like service and service discovery over there. The problem is, see, if you have 100 node cluster, right? Think of 100 node cluster, or imagine like there are 100 houses, right? And you are sitting in your own house, and you have to talk to somebody who is sitting in some house number 66, and you don't exactly don't know whether that person is in house number 66 or not. That person is also moving around, right? Possibly today maybe he's on one location, another tomorrow in another location. So we need some sort of discovery mechanism in clusters like that. If you are aware of Zookeeper, uh, not really Zookeeper, the uh, literally over here is this service discovery, like who is where. And actually Zookeeper also does that in Kafka. It basically has the information of who is where. So exactly Zookeeper also. And in Kubernetes, we have like simple services concept. So like if this service wants to talk to that service, which is running somewhere in a big cluster, right, somewhere very far away, then what happens? It basically there is a DNS service also, which is having the information about the IP addresses of the other pods which are there. So we have a mechanism in which when this wants to talk to that, it basically talks to the service of that, and the traffic is forwarded to the other pods. So this is just a representation here, and typically it looks like this. So they will be some sort of endpoint object. We call it like this, like my app. The port over here is this. The address can be 10.1.0.1. The other address can be 10.1.1.8, and so on and so forth. So my like all the different microservices which we have, they all will be able to talk to each other, find each other, and then they can talk to each other as well. So we have suggested that go for Kubernetes in future, and we will be able to provide you the functionalities of load balancing, layer 4 load balancing, layer 7 load balancing as well. We can provide you the functionality of having this like being a we can say by having multiple instances of something running, and the cherry on the top. So this is also pretty okay, right? But now I'll show you something which I would like to close my session on, and which is running Spark on Kubernetes, which is the cutting edge thing. And I just know a few of the companies who are doing it right now. And let me see where that diagram went. Oh, there. Okay, so check this out. Okay, now see. So what is Apache Spark? What does it do? Uh, the company we are talking about right now, they also have analytical requirements. They want to do analytics as such. So that analytics which they would like to do, that analytics will be, you can say, will give them the edge on uh, against the competitors. So if and what are the engines which we have on which we can do analytics when we have big amount of data? The engines, you all must have heard about Hadoop and Spark before, right? So these are big data engines as such. Now, so typically when we deploy these big data engines, I have done few sessions just uh, I think last week on Spark and MapReduce. So please go, you can also find that. But today we are going in the cutting edge of that is the Spark on Kubernetes. So Spark engine is basically the engine which is taking care of my big data. If I run any PySpark job over there, or Scala job over there, or a jar file if I execute, then the that particular you can say cluster which takes care of the big data and big data based and machine learning or big data based analytics on my data, giving the outputs as fast as possible is Spark. Uh, that's the one. Now, the till today, what we do is if I show you any picture which I may have from my session, or maybe if I just go and find it for you, just like this, you can also find my session where I created my own diagrams. That will be really interesting for you to look at that. But if you click on any one of them, um, is it okay? Oh, let me just click on this. So you see this cluster manager. The now Spark cluster can be very big. It's big data, so a lot of executors are required to run something. So the cluster manager has various options. Like we used to typically run it on Yarn. Yarn was the cluster manager, and it is also the cluster manager. The main cluster manager popular and so on. So what is Yarn? Yarn is used over there. So that is amazing. Anyways, but it is also possible now that the cluster manager can be Kubernetes. So for any company who is already running their Kubernetes based or their applications are running inside Kubernetes, the microservices are running in Kubernetes, then from their point of view, it makes a lot of logical sense, or it will not make a lot of logical sense to have another big data cluster which is running on separate set of VMs, and that is also costing me. Can't I just double up and use the Kubernetes cluster which I already have, and this becomes the cluster manager, and the density of my applications, or the density can be increased. If the density can be increased, then I don't have to pay extra for the extra resources. So that density is what can be achieved by using your same existing Kubernetes cluster for big data analytics as well. So we have the option now to run Spark inside Kubernetes. So now, when we do that, one of the popular approach which is there is by using this Spark operator. What are operators in Kubernetes? Like operators are custom controllers which we or some company has created and has provided. So what it does, basically in the HCD we get our own table and we can write our own jobs, or we can write our own logics against that table. For example, this Spark operator which I have mentioned here, it was made by Google itself, and it is available and it's open source. It's available in all the you can use it in Kubernetes in Azure as well, and on premises and in other locations also if you're thinking of any other locations. So what this does, it's a custom controller. So basically, when we write any Spark job and we submit that Spark job, so that when that Spark job basically is submitted to the API server, this custom controller picks it up over there. It is listening to the events, like we were talking about, that everybody is listening to everybody. The bindings are there, and we have a concept called as watcher. Things watch each other. So there is a binding which happens, and this is listening to that. So this gets, you can say, it gets that particular Spark application which has been written here. And what can be inside that Spark application? In that particular Spark job, it can be there that uh, that monitor the real time. You can say track what is the user doing on the web app right now, on this app right now. Like what are they doing? Are they on the first page? Are they clicking on this? Are they clicking on that? Or what is their behavior as such? Not their historical behavior. What is the real time behavior which they are doing in this point in time? if I can do the analysis fast enough, what I can do is I can show them real time recommendations, like not set recommendations or previously recorded recommendation. Based on their current activity, we can show them real time recommendations. So once those real time recommendations are being shown, it will. So what you're doing is typically you're customizing your solution for that one user as such. Now, if you do that, that personalized experience can, if you do it properly, can increase your basket size. Which means that if I was just buying this, but you maybe gave me sort of slight discount or showed me the correct next product, which I may would also would love to buy, but I was not aware of that you have it, or maybe it was in back of my mind, but it is related to that. So now I basically buy this also. So basket can be increased. We can have more customized. We can have more personalized experience. So all those type of logics can be executed in Spark in real time. So when we write that logic there, and when we execute that, so the Kubernetes is now responsible for creating a concept called as a driver and executors over here. So this particular word which I'm using, executor and driver, this word is coming from the big data world. And in the big data world, we have executors and drivers. So, but today in this diagram also, these executors and drivers are on the pods. Pods are those logical boxes which are where the containers were running inside uh, Kubernetes. So, but when we enable the Spark operator, or when we enable this Spark on Kubernetes by using the operator concept, we basically are having these executor pods. Now, this makes a lot of sense to me. Now, if I just create one namespace, so imagine this is one namespace over here, like this. And just FYI, that can take care of across namespace jobs as well. So maybe there is another namespace here like this. And this is where my login service, the other services which we were thinking of, the payment gateway, and all those are also running on pods over there. So they are also there in this massive 100 node cluster of whatever number of node cluster you want. And my Spark jobs are also coming up in that same cluster based on my full control is with me. So increase the density, use the Kubernetes as cluster manager, uh, justifies my cost of Kubernetes, uh, and is the is this is the one where we get the best of Kubernetes. Like we get the capability of Kubernetes to do the to understand when things go down. What happens if this executor pod went down? So someone needs to inform back right away. Like this executor went down because of some reason, maybe out of memory you did something wrong, loaded a lot of data over there, doesn't have that much of RAM, and CPU cores are not there. So whatever happened, this crashed. So the Kubernetes has inbuilt mechanisms by the that some replica controller will come up, will understand this, and so on and so forth, and will further scheduler will schedule it, and kubelet will again make it. So all those best of Kubernetes is now with Spark. So this is what we are also suggesting to them, that in future, when you go for your machine learning jobs or when you go for your big data analytical jobs, don't create another cluster. Don't go for that. Just use your existing Kubernetes in the cloud, and put the run the jobs over there along with other things which you have in that. So uh, think I think I even have this open here. Just wanted to show you how easy it is to be enabled. Hopefully this is the correct page. I'll just read it once. I already deployed that. So okay, so just check this out. So that's all. We have the concept of Helm, and I can zoom in. So the package manager is Helm. We are using Helm to deploy the Spark operator, and which is provided by the Google platform. It's on from we are pulling it from there, and we are installing this inside our Kubernetes cluster. As soon as we do this, we will be able to specify any Spark jobs now, which are right now inside. You can say uh, you see this .yaml. That is basically this file over here. So here I have information of where is that particular job. Is that Python file lying in my GitHub repository, or is that Python file lying in some image, and I have to specify the image path then, or is that Python file lying in like where is it? Like, so all those things are there. So local is like the local image right now, local image, which is this one. So it's inside that image over there. So run that. So this is the, and inside this job, I think it may or may not be open somewhere, but inside that job we are doing, that's where the Spark, you can say, code will be there inside that job doing the real-time recommendations. I will be having it somewhere with me. And then other normal things also, like how many drivers do I want, or do I want, how many executors do I want, how much RAM should be there, auto scaling should be there or not, dynamic executor should be created or not, uh, or should I want to take care of my own executors. If I make a mistake over here, then I may end up getting some out of memory errors also. And do I want to, so if I'm an expert in that, I would definitely love to parallelize my Spark jobs as much as I can, and not to parallelize them. Uh, Parallelism will be good till one point. So all those things can further be configured and worked with. So just is deployed like this. So what this brings in is the best of all the worlds, and everything is inside Kubernetes over there. So this is our final suggestion to the Parts Unlimited company, that this is something where we can go towards, go to this particular future as such. So this is what I had for the session. We have around 15 minutes left with us. I'll just answer your questions, and anything which comes to mind you can ask. And if the mics are also enabled, you can also ask me over that. Otherwise, I'll start reading the the questions which I have in the screen. Can we skip npm package files while running GitHub Actions for a web app? If yes, then how? There is literally one command called as skip. Like skipping options are available. You can skip the step if you like the individual step which was there, and you don't want to run it. You can totally skip it. It's available in GitHub Actions.
Hello, Shivam. Good morning. This is Mani.
Yes. Hi.
Hi, it was a great session. So just to add on where you have left on the suggestion to the customer of Parts Unlimited, say customer want to have a unified cloud solution. Say for an example, he would like to have multiple cloud and he should not even aware or he should not even come to know that which microservices is running where. Okay, so that kind of future enhancement. So if that is the case, so what would be the solution for the provisioning, automation, and everything? Do you think Terraform and Ansible would be the next stage?
Okay. So pretty a good question at the right time. I will show you. I had it in my diagram, but I think I am running out of time, so I didn't cover it. But just want to show you that that functionality is available, and it is somewhere over here. If I keep on going right, then this is what we are looking for: multi-cluster services. The services which are going across multiple clusters. Now, right now in this my example, the clusters are on the in Azure only, like in East US and West US, like this. This box represent East US, that box represent West US. So cluster A, cluster B, like total standalone different cluster in two part of the world. But the service which we have, the one which was actually making the front end talk to the middle tier, that particular service in the middle, has now the capability of there's a concept called as service import and service export. So what it does, it sort of like just like it says, like this service A uh, is or this service B over here has been imported to the other cluster in the other part of the world, and still the when service A talks this pod which is part of the service A, you can say hierarchy over there, when it talks to B, it knows where the traffic should go. It knows what's the IP address, and it goes and talks to the pod, which is in a different part of the world. Now, that different part of the world can be another cloud also. Like if we want to create the multi-cluster services across clouds, totally possible. That will be very interesting to create as well. And this is the answer for that. Multi-cluster service supported now.
Thank you so much, Shivam.
So there is a question in the chat. Vivek is sharing one white paper. Let me just open that and see what is the. Okay, so this is the okay. I think this is if you want to add Vivek, you can just unmute and please to add. Is this the multi cloud which we were just talking about?
Yeah, it's the same.
Okay.
No
So
worries. I
guys,
mean, it's just a paper which I wrote way
okay,
back.
he's already has a paper written on that, right? So please use this paper for reference purpose when you set it up. Bookmark this link,
Thank you.
right? Okay. Okay, so I will just also open the learn module, which I can see is there in the chat. So what is the next step? Now we have understood things till here. Now what is the next step which we can do is we can further jump inside the in Azure. And even if you are new to Azure, if I just scroll down on this page, you will see that there are multiple links which are available, which will further go to MS Learn, where in a lot of these modules, we don't even need Azure subscription. They will provide us the sandbox environment. In some of them, we may need our own subscription. So we can go for the free trial subscription, which Microsoft provides. So if I show you that, this is the best step-by-step hybrid model over here, where videos are also embedded, which we can first watch and then just scroll down and click on the next thing, and then we can also uh, have the more detailed like networking on Azure, compute options of Azure. Uh, and if I go one page back, I think that was the page where I was able to see compute services. So if they are very kind, they will be also having Kubernetes there. And if I click on this is just what we just talked about. So if I want to know more about containers, and I would like to know more about how can I do it in Azure platform, I can just watch this video and then know what's more about microservices, and then further go into more advanced things uh, based on my own pace. And this is the step-by-step learning guide or plan or approach which we can take to further move or gain more excellence in the cloud platform. So please bookmark this link. And this is thanks Rashmita for sharing this. And this will be the next step from today's onwards like that. And join us for other sessions in Reactor. And that will also help you in staying motivated and staying on track. Okay, questions, please. Anyone think of if anything comes to your mind, you want to ask anything as such. We have around 10 minutes with us. And yes, please join this the Reactor group. We do a lot of amazing sessions. A lot of different speakers are there. We have best of the best speakers coming and speaking on these sessions. And if you join this Microsoft Reactor India over there, you will get the updates on the next upcoming sessions, and you will not skip anything which you would like to go through over there. So that's one thing. And after this, I can also see that so this is the on link that's on LinkedIn, and here we have this is the meetup page. So if you subscribe to this meetup page, if you have not already done it, and you came maybe through some other mechanism, then that's where you will definitely find the upcoming sessions here. So this is going on, and then the next one over there. And the Reactors YouTube link is also there. That's the location. So if you see the Reactors YouTube link, the second last link in the chat right now, that's where all the recordings are available. So this session will also go there. And the feedback is the last link, and feedback is very important. Your feedback help us in doing the improvements and changing our ways. So all of those things. Okay, are there any sessions on Azure to deploy Java applications in Linux environment? We actually, I think 2 weeks back, we also did one session which was like where we used the Spring Cloud, and we used Azure Spring Cloud service, and we deployed Java-based functions, and we talked about the entire what is the meaning of Spring Cloud and all the details around it. That's one, and we have the series which is coming on Azure for Java developers from May onwards. So you can look for both of them.
Any other questions, folks? We still have another 5 minutes before we wrap up today's session, so please feel free to unmute and ask question. Also, Shivam's coordinate you will find on the meetup page. If you have any questions later, you can always feel free to reach out and ask questions to him.
Yes, Azure Spring Cloud is already, that session is already uploaded on YouTube. So you can find it from the past events over here. And please ask a question. If I can see that event, if I can see the name of it, I'll just give you the link. You can further trace it on YouTube with that.
The best way is always go to our Reactor YouTube channel and you can get all our videos there. That's the best practice. But however, if Shivam can send that link to you, that would be great. Otherwise, always please, the best practice is the YouTube Reactor channel. Okay, then I don't think we have any more questions, Shivam. So thank you so much for today's session. It was an amazing session. And thank you all for joining us today. Please do share your feedback about today's session. Also, please feel free to use the Learn module link shared in the chat section. This will give you access to additional resources to take your learning further. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming sessions. Thank you all once again and enjoy the rest of your day.